the OpenSciEd teacher video series for 6th grade, Unit 6.2, the Thermal Energy Unit. My name is Chris. I'm an OpenSciEd 6th grade teacher and facilitator. This is the anchor lesson for this unit. And I love anchor lessons because they always generate lots of excitement and lots of questions, and they just set you up for a great few weeks teaching the unit. This video will be divided into kind of 3 segments. Briefly, I'll share the lesson outline, highlighting some key moments throughout the lesson. We'll dig into those key moments. I'll share what's happening, things to look for, things to be careful of, and lastly, I'll have a few materials management suggestions and tips and tricks for you when teaching this lesson. So let's take a look at what it's all about. First of all, as I mentioned, it's an anchor lesson. It's the start of the unit. This anchor is designed around 3 days. I've put 20 to 30 minutes for material prep each day. A lot of that is really just making some posters with headings so that they're ready to go when you're ready to work with students. There's not a lot of equipment involved. There is one demonstration that involves a couple of cups. There are no need to have any kind of devices for this lesson. There's no extra videos. And the question that it kind of focuses on is just like, why does the temperature of a liquid in some cups change more than in other cups? This is kind of the big overview of those 3 days. You can notice that each day is broken into a couple of smaller chunks. And let's dig into those now. So on day 1, the kids get introduced to the phenomena of the cups, and we do this quick investigation to prove something that they kind of already know. Fancy cups work better. And the key moment, though, is when they try to show that and shift to the idea of why using a model. On day 2, students take their individual ideas as to why and merge them together as a class to see what things we all agree on. And we also bring in some related phenomena, other stuff that keeps things hot and cold. And then on day 3 is this great moment. We capture all of our lingering questions. We post them publicly and then brainstorm ideas on how we might get answers to our question. Throughout this lesson, we figure out a few things. We figure out that cups are actually systems with parts that have things like lids, walls, liquids, air, and maybe some other things. That fancy double-walled cups keep drinks colder than plain cups. We find out we don't really understand why that works, and so we have lots of questions, and we have some ideas about what we're going to do to answer our questions. So let's dig into our key moments in this lesson and where you want to dig in and linger with your students. In the beginning, and the very first day, students are asked to create an individual model of the 2 cups, the plain cup and the fancy cup, because they know what happens now because you've done it in a demonstration, but this is this moment where they shift from knowing what to trying to say why it happens. And they will be all over the map on this one. They're going to have lots of different ideas about what's going on. Some of them may be real. Some of them may be misconceptions. They're going to talk about heat, cold, energy, temperature, and a host of other things. The unit will address it later. Embrace it. Don't try to correct anything. Don't try to change anything. Just let them surface those ideas. Because then in day 2, in part 8, you're going to come together as a class in a scientist circle, and you're going to create a consensus model. What is our whole class's ideas about everything that's going on? And this is where you're looking for that shift from, I think this is happening, to we all can agree something is happening. And the goal is, again, to surface all kinds of explanations. And this can be really messy. The teacher's guide has a really nice, almost picture-perfect consensus model, but these 2 are from my room, and you can see that depending on who we're talking to and what's going on with each class, they can be very, very different from day to day. So it's okay to be a little messy at this point. Also in day 2, there's this moment where students try to come up with other ideas for things that also keep something hot and cold. This is really important. Don't shortchange this. One of the things we hear a lot is this unit is all about cups, and it is not. It's about energy transfer and thermal energy. And by doing this part in particular, kids will realize that there are other things that they know about that they want to be able to explain. It gives you something to talk about on a day where the kids are sort of groaning about cups. And by the way, one key part of this that really sort of enlivens kids is that column on the right where it says, how does it work? So after they give you an idea and you ask them whether it's going to be something that keeps something hot or keeps something cold, make sure you ask, well, how do you think it works? And try to get their thoughts on that. It'll give you some really key insights on what they are thinking, and it'll make them question what they know and don't know, which is really important for when you get to part 12, because kids are going to now have this chance to surface all these questions that they realize they're uncertain about. They will have lots of questions that are kind of similar to each other, group those up into some general categories, and it's really important that every kid shares at least one question. That way their voices are heard in this very public and very grounding space, because it is these questions that you're going to answer throughout the unit. And lastly, the last key part here is part 12, where they say, well, we have all these questions. What are we going to do to answer those questions? And get a few ideas, give them some time to brainstorm, and then this will lead to what you are going to do the very next day. All right, a few little things for you about some materials management and some things you're going to need. The first of all, you're going to notice the list of materials created and to save for future lessons is pretty big, and it is the same. A couple little ideas for you here. If you are short on space and don't have a lot of wall space or chart paper or whatever, it is certainly okay to have each class do this individually, but then to make a summary poster that kind of includes all the kids' ideas or from across the different classes, and share that with them. That these are ideas from our class and other classes. The other thing here is these do not have to be perfect. They are absolutely working documents. You can add to them anytime you want throughout the entire unit, and you probably should. As kids get more questions or they get more ideas for things that they want to do, or whatever it might be. One or two little things with materials. When you're doing the demonstration with the cold cup test on day 1, don't use ice in the cups. Strain it out. It will not give you a clean data set if you do, and it may even be add some controversy. The other is I always like to have different colored sticky notes for each one of my classes when we're making our driving question board. That way they can quickly identify which questions came from their class as opposed to other classes. But having them all up there is really important. There are a couple words that they'll encounter here. One is the idea of an open or a closed system, and you can define that with them if you like. The other is the idea of a model or modeling, and the idea that models contains parts, interactions, and changes that happen within a system. That's the key to the anchor lesson for this unit. It will lead you to the next part where they do a much broader test themselves of some different cups. And I hope that you have a great and successful start to the unit. Good luck.